Hello everyone, my name is Antonio Tavera and I am one of the authors of the paper Pixel by Pixel Cross-Domain Alignment for Few-Shot Semantic Segmentation. In this paper, we look at the problem of semantic segmentation in self-driving applications. Since data annotation is time-consuming and costly, we consider the few-shot setting in which just a few annotated images from the real target domain are needed. This setting defines k-shot as a task providing k real images randomly selected for each of the m cities of the target dataset. One of the most difficult aspects of this work is dealing with the inherent imbalance between source and target data, which concern both the visual domain shift and the cardinality of data. This issue is even more complicated by the intrinsic pixel-wise imbalance among semantic classes. Some classes are both extremely frequent and spatially extended, like road or sky, while others may appear seldom and be small in size, like traffic sign. This imbalance causes overfitting towards well-represented classes and less accurate mapping or negative transfer of those classes that are underrepresented in the target domain. To address these issues, we propose a novel framework that we call PixDA, comprised of a novel adversarial loss that analyzes each pixel individually. We use a pixel-wise discriminator whose goal is to discern for each pixel what domain it belongs to, and we introduce a novel adversarial loss function that we call PixAdv, designed to align each pixel according to its importance. In particular, to determine the strand with which each pixel is aligned, the PixAdv loss modulates the adversarial loss according to a combination of two different terms, each with a specific purpose. The term S is related to the network classification confidence, and it is considered as a measure for each pixel of the ability of the network to represent it. The term B represents the imbalance of the pixels and aims to rebalance the class's contribution based on their frequency in the target dataset. Through S and B, we are able to correctly balance the adversarial alignment, resulting in a more heterogeneous and effective adaptation. Due to the extent and variety of the synthetic source dataset, there will be source samples far away and detached from the target domain, for example with a different perspective or illumination condition. Forcing the alignment to these samples can result in negative transfer from the source domain. With this in mind, we propose a sample selection procedure that, working side by side with the PixAdv loss, enhances the use of the source data by identifying and selecting source samples that are better aligned with the target semantic distribution. We assess the performance of our method on the two standard synthetic to real benchmarks used in the domain adaptation literature, GTA to cityscapes and Cynthia to cityscapes. We compared our method to the several baselines here listed. We observed that our method not only works well with predominant classes, but on average it improves the recognition of semantic categories that are underrepresented. The results are qualitatively confirmed in these following images. The source-only prediction showed that the domain shift between GTA and cityscapes is lower in some major classes, like the road or the vegetation, but that is not true for some underrepresented classes, like the bus or the train. Even fine-tuning with few target images suffer of similar problems and in some instances produces completely wrong prediction. Look at the rider classified as a person, or at the bus completely misclassified. PixDA instead perform consistently in all the settings and provide good predictions across all the classes, being overall the closest to the ground truth. Concluding, we present a pixel-by-pixel adversarial training strategy that uses a novel pixel-wise loss and a pixel-wise discriminator to better align source and target domain and to reduce the negative transfer problem. Our framework achieves the state-of-the-art performance in all the 1 to 5 shot settings. That is pixel-by-pixel cross-domain alignment for few-shot semantic segmentation. Thank you for your attention. For more information, look at the main paper or scan the QR code here provided.